Azure AI and ML with Sam Nasr.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast, deliver quality, and to run your software with confidence in Azure, all while using everything that the .NET ecosystem has to offer. This episode is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results. They are hiring. You can go to clearmeasure.com/careers. Positions include hiring architects as well as .NET engineers who'd like a path to become an architect. And then finally, be on the lookout for some upcoming announcements on a new video show. The guest for today is a repeat guest, Sam Nasr. He's a IT consultant specializing in .NET, SQL Server, and Azure. He's a senior software engineer focused on the Microsoft stack of technologies, is where his deep focus is, including Azure and artificial intelligence and ML. As part of NIS Technologies, he provides consulting services, training, and custom app development to help bring more value to business applications. He's also a leader at the Cleveland C# and VB.NET user group. Sam, welcome back to the podcast. How are you, sir?
Very good, Jeff. How are you?
I'm great. Tell you what, ready for spring.
Yeah, makes two of us.
Well, welcome back. For the listeners who maybe didn't catch you on your previous episode, I always like to kind of ask the guests the high points in your career that kind of led you up to what you're focusing on today. A little bit about your background.
Well, actually, so as far as Azure AI and ML, basically I kind of stumbled on it. I came across a video from Build 2016, where I believe the gentleman's name was Saquib Shaikh. And basically, he's a blind engineer, and he works for Microsoft, and he started developing services that help him to get by day to day. And naturally, these services were made public. So these were services such as vision and speech, and it allowed him, being as a blind person, that he would be able to use his phone or the camera in his phone rather, to be able to identify the world around him. So he'd be sitting at a restaurant and he'd pull up his phone, and with the app, he can read the menu, or it would read it to him. Likewise, he could hold up the camera for the people around him, and it would tell him who his guests were. There's a gentleman sitting across who's smiling. There's a young lady who's acting surprised. So it's helping to identify the world around him. And I thought that was really amazing. I mean, and we're now taking software development to a whole new level where it's not just business applications or building video games, but now we're just helping humanity altogether. And so I thought that was really quite a moving video. And I started looking into cognitive services and kind of got hooked on it and started diving more into AI and ML from that point.
Wow. Yeah, there's so many interesting applications for what computers can do for us.
Absolutely.
Well, besides what Azure can do, for those listening who maybe have heard of artificial intelligence or machine learning, but don't know which one's A, which one's B, are they the same thing? Are they totally different? Can you help us with the layman's definitions just to ground us?
Sure, absolutely. So without diving into too much detail, because I know many people listening aren't mathematicians or physicists, and neither am I, quite honestly. But the beauty of these services is that they have been democratized by Microsoft, meaning if you can make an API call, you can utilize AI and ML. So to describe how they relate to each other, imagine an onion, if you will. The deep core is the neural networks and the deep learning aspect of it. On top of that, we build machine learning that uses algorithms to be able to solve problems. And then the outer layer, which builds on those bottom two layers, is AI, which essentially allows the application to function the same way the human brain works. So several layers. You have AI that builds on top of ML that builds on top of the neural networks.
Okay. So in order to use AI, you're effectively using ML as well?
Exactly.
Gotcha.
Right.
Okay. Now, do you have to be using some of the Azure services for this, or how does that come into play?
So in most cases, you can be using the Azure services, specifically Azure Cognitive Services. Most of them, with a couple minor exceptions, need to utilize the service. So you train the model within Azure, you're deploying it within Azure, and then when you use it, you're actually making a web API call and you're consuming that model that you built in Azure. But if you look at ML.NET, for example, you can take your existing .NET application, add in a new class library for the machine learning model, train it, and deploy it all locally using your local machine. So on the other side of it, you can also leverage Azure ML, where you can utilize the Azure services to be able to build your model using the Azure data centers. So you're no longer tied to basically consuming a lot of time on your local servers to train that model, but rather you can use the Azure servers to train it.
Do you have any favorite AI or ML projects that you
My
can
favorite
share?
one is Lewis, the Language Understanding Intelligence Service.
Okay.
And the thing I love about that is that, again, it kind of functions the same way that a human functions, where, if I'm talking to you, I'm just using natural spoken English. And it's the same way that I can talk to that app as well using Lewis. So let's take, for example, that we're in a car dealership and you're the salesman. I walk in as the customer and I'm saying, do you have a red Corvette to sell me? Or I would like to buy a red Corvette. Or I'm interested to see what Corvettes you have in stock. All three are essentially relating to the fact that I want to buy a car, right? That's my bottom line intention. All three phrases were phrased differently, but the same intention applies to all three. So you as a human understands that I'm after buying a car. It's the same thing with Lewis. Once I set it up and train it on all the various phrases, now I can talk to it the same way I would talk to a car salesperson, and then it would respond accordingly.
Hold on. All right. So is this a like a NuGet package? Is this an Azure service? I'm just thinking. Okay, wait a minute. I can write C#, and how do I get from, I guess, listening to a microphone somehow to I'm running some sort of code doing something?
Okay. So first of all, with Azure Cognitive Services, it's a variety of different services. There's some for language, some for speech, some for vision and decision making. And that's basically the four major categories. I won't get into the open AI, which is in preview right now, but let's just take a look at those four. And more specifically, let's take a look at the language and speech. So the speech services, they allow me to convert speech to text and vice versa, text to speech. And then looking at the language services, there is the Lewis service, which is under that category. And that helps to understand basically natural spoken English or natural spoken language, since it works with other languages as well.
Mm-hmm.
So the way I would train it is I would go into a Lewis.ai portal, and then I would set up my model, train it on a variety of different phrases that are typed in. I want to buy a car, sell me a vehicle, do you have a red Corvette in stock? All these three phrases, right? I train the model, I get it to the point where it understands that any of those phrases mean that my intention is to buy a car. So now when I enter in that text into that model, it knows the intention is buy car. That's how it's trained. So now I can take that model and be able to utilize it through Azure Cognitive Services, where I make an API call and I send in a text string that says, I'm looking for a red Corvette. And then it will come back with an intention saying, oh, this user wants to buy a car. Now in my app, I can go and once I've identified that the user's intent is to buy a car, I can say, well, Mr. Customer, here's a list of our inventory of vehicles, or more specifically, our inventory of Corvettes. Which one would you like to look at? So essentially in my C code, I make the API call, I get back a text token that says, that this user's intention is to buy a car. Now I can process it accordingly, where I can search my database and produce a list of cars and display that to the customer.
So you're talking about the text string and the car intent. How do we go from a microphone listening to what you're saying to the text string? What piece handles that?
So remember how I said that Azure Cognitive Services divided into 4 different areas, one of them being speech? So I've already built my Lewis model, and that takes a text string. So how do I go from a mic to a text string to an API call?
Yeah.
By using the speech service, I can now have it so that it listens and it will extract that phrase, I want to buy a car, convert it into a string, send it to the API. The API will then respond back with the token that the user wants to buy a car. And then I can search my database and display a list of cars to the customer.
So going from an audio file essentially to the text string, does that happen on the end device, or do we send the audio file to Azure?
So with that, it would happen locally, and then I would believe it happens locally. I'd have to look at my project again. No, I take that back. It happens in the Azure service.
Okay.
That responds with a string. Then I take that string, pass it to the Lewis service, and the Lewis service comes back with the intent saying the customer wants to buy a car, and then I process accordingly after I know what the user's intent is.
And once I know what the user's intent is, I can respond back and then convert it back into speech if I want to, and then a computer just talks back to them?
Yeah. So let's say I find out after I search my database that we have 14 Corvettes in stock, for example, which is something that I dream of every day, having 14 Corvettes. But in any case, so I find out I have 14. Then I create a string that says we have 14 in stock. I then take that string, pass it into a text-to-speech service, which then comes back with a WAV file, and then I read that or I run it to the customer. Okay. And so they would hear we have 14 in stock.
So it sounds like the old automated voice systems on a telephone, but you had to say the exact phrase that it was looking for. But it sounds like now the intelligence is a lot more forgiving on how you might ask for things, right?
Absolutely, right. So before you had to say customer service or buy car, and now you just talk to it just like you would a normal salesperson. And this also hinges upon training the model correctly. So if you don't train the model correctly, it's not going to act properly. But once you train it and you have the right phrases in place, pardon me, once you train it and you have the right phrases in place, then it can respond correctly with the right token.
Yeah. And so really, a lot of us have been trained by the old systems to just say real person, representative. Wherever we think will get us through.
Yeah, and sometimes they say it in a very angry way too. So
right, yeah, shouting the phone, real person. Sweet. So if the processing is happening in Azure, we're just making. Now, are we making like JSON web service calls, or are we just calling a C# SDK, which then handles the jumping over the wire for us?
So either one would work. If you want more granular control, you would use the API calls and you would make the call to Azure. However, there is an SDK available where you submit the keys, and then it takes care of all that on the back end.
Mm-hmm.
So either one would work.
Gotcha. Okay. So then the computer or device running my code doesn't sound like it has to be that powerful. Am I wrong about that?
As long as you have a good internet connection so it can make those API calls, yes. And again, I want to reiterate that some of the services, you can't have the model placed on the device. So for example, like with object detection, which is part of the custom vision service. Once you train that model, you can have it run on your individual device. Lewis, on the other hand, or the language understanding service, that needs to run in the cloud. So yeah, if I'm using the language service and the speech to text and text to speech, then all that is running in the cloud. I make the API call, I get what I need, and then I proceed on with my processing.
Gotcha. Okay. So you mentioned it, we kind of glazed over it, training the model, and which gets me back to, okay, I'm writing some C#, doesn't sound like I'm writing a ton of C# just to facilitate the process, and maybe I have some set of queries or commands that my system supports, and I'm just interfacing back with voice. But what is the testing method, the automated unit testing, integration testing for this type of application?
So let's take a look at the first core part of it, which is the model itself. And that is essentially a library that I'm training in the Azure cloud. And I train it by submitting various phrases, and I let it know that the intent is buying a car. So if you submit the phrase, again, I want to buy a car, I'm looking to purchase a vehicle, all of these are different sentences, but they have the same intent. And so as you're training it, you put in different variations, and it will learn over the course of time that other sentences related to it, without you specifically saying, I want to buy a car, it will know that other phrases related to it have the same intent of buying a car. And what will happen is it'll start producing a score of how confident it is that that is the right intent. And once you get into the 70s and higher, then you know you're in the safe zone as far as the intent coming back. It will produce a JSON result set, and it will reply back by letting you know the highest scoring intent, meaning if you consider that in a car dealership, you can also get your car serviced, you can get it washed, you can trade in a vehicle. So you're going to set it up for a variety of different intentions depending on your business case. It will always come back with the highest intent that it thinks is the right one for that phrase. And it will also produce the other intents, but with a much lower score. And so you take the highest intent and you process it in your app depending on, again, am I buying a car? Am I servicing a car? And you train it for a variety of phrases. Roughly, you want to go about 500 phrases per intent. And that way it will put you in the clear area. So that way that the application won't error out over time.
Okay.
You definitely don't want your user yelling operator at the end of it, right? So
Right.
you want to train it well. And so once that model is created, now you can utilize it through the Azure service by making an API call, and it will respond back with a JSON result set.
Nice. Okay, so there's been something else that it's released, it's out there. Microsoft kind of touted it at some Ignite conferences and Build conferences a couple years back. Does this relate at all, or how does it to the bot framework?
So the bot is very similar in the sense that you have an SDK where you can essentially have a give and take conversation. And a perfect example of this is one of the auto websites online. You notice all my examples revolve around cars, right?
Mm-hmm.
I'm a huge car buff. So one of the website for selling vehicles, basically, I was on it on a Sunday evening, and a toast message popped up on the right side and said, "How can I help you?" And I started asking questions. Is this car available? What's the mileage on it? Blah blah blah. It responded to most questions, but then at the end it said, "Give us a call Monday morning because we're closed now." And so the advantage of that is I had the ability to interact with the application on a website, and it had that human interaction, a lot of give and take. And even though it was Sunday night and the dealership was closed, I still wasn't left out in the dark. I got a lot of my questions answered. But then when obviously went down deeper in the rabbit hole, it said, okay, you're going to need to call on Monday morning, right?
Yeah.
But for that period of time, I was able to have a conversation and not feel like I was just stranded. So it provides businesses the ability to have 24/7 service, access to their data in a very human-like way, as if you have a customer service rep on the phone 24/7 or on a website interacting with you.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery.
For those things where you might have been just as happy to say, hey, do you have an Excel spreadsheet with all of your inventory data? Can I look at it? you might, you still get access to some data that they would happily give you if you were on the phone with a real person.
Absolutely. And you touch on a key point there. So every organization has historical data, stuff that they've collected over time. What can you do with that data other than just save it for X number of years and then purge it? You can actually build a machine learning model around it to learn from your previous sales and be able to predict future sales and forecasting. So you already have the data. You can make it available to your customers, like you said, or you can use it for machine learning and build on it for forecasting and predicting sale prices or just your overall gross sales in the future.
Mm-hmm. Gotcha. All right. So it sounds like for testing, I certainly would write unit tests to test my own C#, but it sounds like I need to have some type of integration tests around my model to make sure that, if I have 14 examples that be, slam dunk 100% matches, I want to constantly with every build be testing that I haven't accidentally screwed up some of my mainstay examples. Am I on the right track?
Absolutely. Right.
Okay.
So you would essentially test it the same way you would test an API call, because in the end, it's nothing but an API call, right? And just like all APIs, you submit the request with specific parameters, and then you get a JSON result set back, and then you can dissect that result set to see, is the phrase that I submitted, did it come back with the right intent? And does that intent have the right score? Meaning, is it 70 or 80%, or is it below 40%?
Okay.
If suddenly it fell below 40, then something is wrong. Your model somehow got corrupted, or needs to be trained, or maybe you're pointing at the wrong model altogether.
Yeah.
So you would test it just like you would any other API.
Gotcha. All right. So extending this, we talked a lot about machine learning, and you said artificial intelligence kind of layers on top. Where would we take it further, or where does AI fit in here?
So, like I said, you have the neural networks, and then you build the machine learning on top, and then AI on top of that. So with AI, the whole point of it is it's providing thinking in the same way that a human would. So it provides that human interaction, so to speak. So, like, for example, the language is a perfect example of it. Natural spoken English. Another thing is I can utilize the Q&A maker, which I can submit a document of questions and answers, and then by typing in a slightly varying question, it will come back. It will search the document, and it will come back with the answer from that. And that's also a very easy service to implement, and that leverages the AI capabilities. So think of it this way: if I was to give you a document that had a lot of the frequently asked questions regarding an oil change, for example,
Mm-hmm.
right? And in it, the details, you need to drain the oil first, replace the filter, refill with oil. Then I come and ask you, what would come first, the oil change, the changing the filter, or replacing the fill plug? And so searching through the document, you would get an idea that this is the procedure that needs to happen. So you need to put in the fill plug first before putting in the new oil, for example.
And we can have the code respond back with something like that?
So again, it's a service that would read that document, and you would make a call to that service. And then when you get the answer back, then you would use the answer in your code.
Okay. And which service is this now?
This is the Q&A maker.
The Q&A maker. Interesting. Man. It sounds like those Microsoft teams are pretty busy just coming out with all kinds of new ideas for APIs.
It really is amazing. Yeah.
Okay. All right. So, in the actual real applications, does this tend to work the best with server applications, or have you also seen it be successful or in desktop or mobile or IoT systems on a chip? Where's the bread and butter currently?
So usually it's all done within the cloud. But again, in some cases where you can have the model sitting on the machine, and depending on how big the model would be, so you may have it sitting on the machine. In some cases, like for custom vision or doing machine learning, You can have the model locally, and that could run on a variety of different devices, again, depending on how big the model would be. But in most cases, most of the services are actually run in the cloud.
Okay. One of the ideas I had, and you tell me if this is a decent application for it, is having a little camera on a small computer or system on a chip, camera at the front gate of our ranch, just motion detecting when cars there, take a picture of it, see if we could decipher the license plate and get that out. Otherwise, just try to detect what it is. And then at some point, fill in a couple gaps and get to the point where we could say, this is my friend. Let me call my wireless gate opener and just let him in. And there's a little speaker by the gate and it says, welcome, Sam. Come on in. Or recognize that it's a delivery truck and I just kind of keep a record of, oh, they came at this time, if I could see the license plate or whatnot. And then just, would that use some of these services?
Oh, absolutely. So that's one way of doing it. And there are examples of IoT devices out there that do just that. We use it as a security in a parking lot where it's tracking all the vehicles entering the parking lot versus all the ones leaving. And so it'll capture all the license plates as well as the vehicle itself. So it'll read the license plate and decipher that into text so it can be stored and searched later. Or you can use it for identity purposes. So you can identify, oh, this is Sam. I'm going to let him in or call the police, depending on the case may be.
Yeah. All right. So I asked you about kind of the mindset of testing all the different pieces here. What does it look like to deploy, a new release candidate from environment to environment and then to production? Like, okay, I made a code change. What does that look like? The promotion process of an application like this?
So again, it's all hinged upon the model. If we're using all the calls to an API and that those calls are going to an Azure service, once I build a model in the cloud, I have the ability to preview it, and then I also have the ability to publish it. And then it also gives me the ability to have version control. So if I make changes and I enhance it, I can update the version and deploy it out again. If I want to test it and just make it limited accessibility, I also have that option. So again, think of just how is it that you would make a change to an existing API, right? We've all published APIs in production.
Yep.
And after we published them, we had to make changes. So we produced another version and published that out. It's the same thing with the model as well.
Okay. So this model is a bag of data, it sounds like, right?
It's an algorithm, essentially, yes. But it looks up on the entire bag of data, if you will, and then it produces an algorithm. And then we can access that algorithm to get a yay or nay or get a token back that would indicate what the user's intent is.
Okay. So when we say the model, is there one model, or do we have, this is the model that's on production and this is on UAT and this is on our development team's TDD environment? Am I thinking about that right? That you're going to have a different version of the model on different environments?
You can. So like I said, you would publish it in preview, and you can also publish it for production use as well. So yes, you can have it in different stages.
And the model, is that something that you would commit to a Git repository, or is that more like a blob, a file, or a SQL Server database?
So that's more, again, if you're talking about something that you're doing in Azure, that's going to be sitting in the cloud, as opposed to a model that you develop locally. That's something that you can put into a GitHub or a repository.
Okay. So it's human readable then. If you were to train a model and then look at its guts?
Not
really.
Quite. I mean, it's so a perfect example is adding machine learning to a .NET application. You can do that, and it will generate a .zip file for you. And anytime we see a .zip, we know that it's a combination or culmination of various files zipped up together. However, once you start looking into it, it's really gibberish on the back end. It is not intended for a developer to go in and modify that zip.
Okay.
It is a model that is built by the SDK, and then you use that model, but it is not intended for you to go in and dissect it or or make changes to it.
Okay, not diff friendly.
Right.
Got it. Just okay. Awesome. So then if you find a bug, the bug might be in the code, or the bug might be in some new training of the model.
Right. So now you're looking at the data that you're training the model on. And so if, like the old adage, garbage in, garbage out.
Yeah.
So if you're not getting good results, it's because you probably trained it incorrectly or not enough records. So you need to have a good representation of your data. It's got to be clean, and then train it on an appropriate number of records. Typically, the more, the merrier. But of course, every scenario is different.
Yeah.
So that needs to be addressed as well. So the model, when you're testing your code and you get the wrong results back, ensure that it is not in your code, first of all. And then second of all, check the model separately to make sure that the results you're getting back from it are accurate. And if not, then it would probably be advantageous to retrain the model at that point.
Gotcha. Yeah. I can imagine with the speech, there's so many people who have different accents. Even if we think that we're speaking English, there's so many different ways to speak English. And I'm sure that is with every other language.
Right. So as far as language, if you have a scenario where someone has a strong accent and it can't decipher it correctly, you should give them the option to actually enter in the string that they're looking for, or the question or the comment. So that way you can bypass the whole accent issue and be able to get the application functioning.
Nice. Well, these examples are fascinating. I know some of the listeners are saying, okay, can I see some of these examples? Do you have some favorite open source end-to-end applications out there that use these things?
Even better, actually, on my YouTube channel, I have a couple of presentations that I made regarding Lewis and the language understanding service. In addition, I've done demos regarding the speech to text, text to speech, also use the anomaly detector and the content moderator. So a variety of them are listed on my YouTube channel. So listeners can feel free to go and check that out.
All right. We'll make sure to include those links in the show notes. Fantastic. Yeah, it's always great to be able to go in something concrete and get your hands dirty.
Yeah, especially with something like this where it's kind of like pie in the sky. I'm making my code interact like a human. How do I do that? Absolutely. But once you get started, it's really a lot easier than you think it was.
Nice.
Like I said, Microsoft has really done a great job in making these APIs very easy to call and to train the models.
Okay. Now, so many developers have the Visual Studio subscriptions where they get the persistent $150 a month Azure every month. Are these really expensive services, or would playing around with them fit really nicely at a small budget?
As far as playing around with them, it's not very costly. Now, if you're running it, in a 24/7 operation and you're using it for production use, yeah, you could end up draining that budget. But as far as a dev going in to experiment and create some proof of concepts, it's not costly at all.
Nice.
As a matter of fact, I doubt you'd even see a budge in your budget or in your allocation.
Okay, fantastic. That's good to know. Yeah, there's some of the services where it charges a penny at a time, and then there's other services just to turn it on. It's like $50 a month.
Right. So, and some services, if you forget to turn them off, it could literally drain your entire allocation.
Right. So. Awesome. Well, thanks. We'll include all that in the show notes. For people who want to kind of dig in right away, is there anything else we haven't mentioned that they really need to hear?
No. However, if any questions come up, I would love for people to reach out to me with a question, excuse me, and how I can help them. My email, samnasr@live.com, SAMNASR @live.com. And I have it plastered all over and in every presentation. I would be happy to help with any demos or any issues they come across.
Fantastic. Very generous of you. Awesome. Well,
Thank
thanks
you
so much for coming back on the show and giving us an update on Azure AI and ML. It's fascinating. I learned a ton, and I'm sure the listeners did too. So thank you.
Thanks, Jeff. Always a pleasure.
My pleasure. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.